nature of consciousness has long puzzled scientists, philosophers, and the general public alike. How do our subjective experiences arise from the complex interactions of neurons in our brains? Can quantum physics provide a new perspective on the mystery of consciousness? Nobel Prize-winning physicist Roger Penrose and anesthesiologist Stuart Hameroff have proposed a groundbreaking theory called orchestrated objective reduction, suggesting that consciousness might originate from quantum processes inside neurons.
One of the important ways you can tell something about consciousness is what turns it off in a reversible way. In Stuart's job, he's an anesthesiologist. He puts people to sleep. Well, I think he would complain if I say putting it to sleep, because under anesthetic is actually different. You make them unconscious in a reversible way. You want to make sure that you can wake them up again. And it's obviously a very skilled thing. But I guess a lot of his colleagues might be skilled at doing it, but don't ask the questions about what they're actually doing from the point of view of the biology and the physics and so on.
The Orch OR theory persists that consciousness arises from quantum processes within neuron microtubules, challenging the current explanations provided by neuroscience, biology, and physics.
These little things called microtubules are absolutely fundamental to consciousness. Not all parts of the brain are the same in this respect. You see, you've got the cerebrum. This is the part at the top, and divided down the middle. And that, when you see brains, that's what you normally see with the convolutions. But right underneath and at the back, there's a thing called the cerebellum, which looks more like a ball of wool or something. And the cerebellum seems to be completely unconscious. And it has comparable number of neurons, far more connections between neurons than the cerebrum. And it's what takes control when you're driving your car and you're thinking about something else and you're not thinking what you're doing because it's unconscious. And the unconscious control, a pianist who's very expert and moves the fingers around and plays a note with a little finger, that pianist doesn't think, well, I've got to move that muscle this way and this bone that way and so on. And it's all controlled unconsciously. And a lot of this unconscious control is done somewhere else in the cerebellum when you get really skilled. It seemed to me, okay, you've got different kinds of structures, and it could well be that these pyramidal cells, which have a particular organization of microtubules, are the ones where the consciousness is really coming to light mainly. I don't know, there's a lot which is not known about this, controversial and all sorts of things. But the cerebellum seems to be different and organized differently. So it's not just how many neurons, how many connections are there, because there are more in the cerebellum. So it's not that.
Microtubules are tiny tube-like structures that form the cytoskeleton of cells, including neurons. Penrose and Hameroff argue that these structures might act as quantum substrate, allowing for the emergence of conscious experience. In his influential book, The Emperor's New Mind, Penrose speculates that the collapse of quantum wave functions could create moments of awareness, linking the physical and mental realms. This idea of wave function collapse, a fundamental concept in quantum mechanics, describes a transition from a quantum superposition to a definite state.
You see, it's very curious the way the history has developed in quantum mechanics, because very early on people thought there was something to do with consciousness, but it was almost the other way around. You see, you have to say the Schrödinger equation says all these different alternatives happen all at once, and then when is it that only one of them happens? Well, one of the views, which was quite commonly held by a few distinguished quantum physicists, that's when a conscious being looks at the system or becomes aware of it, and at that point it becomes one or the other. That's a role where consciousness is somehow actively reducing the state. My view is almost the exact opposite of that. It's the state reduces itself in some way, some non-computational way, which we don't understand, we don't have a proper theory of, and that is the building block of what consciousness is. So consciousness is the other way around. It depends on that choice which nature makes all the time, when the state becomes one or the other rather than the superposition of one and the other. And when that happens, there is what we're saying now, an element of proto-consciousness takes place. Proto-consciousness is, roughly speaking, the building block out of which actual consciousness is constructed. So you have these proto-conscious elements, which are when the state decides to do one thing or the other. That's the thing which, when organized together, that's the OR part in Orch OR. But the Orch part, the OR part, at least one can see where one's driving as a theory. You can say it's the quantum choice of going this way or that way. But the Orch part, which is the orchestration of this, is much more mysterious. And how does the brain somehow orchestrate all these individual OR processes into a genuine conscious experience?
Recent experiments have not supported a gravity-related quantum collapse model for consciousness, leaving the Orch OR theory open to criticism. One of the main objections against the Orch OR theory is that the brain seems unsuitable for hosting quantum processes. Quantum mechanical laws typically apply at very low temperatures, where quantum effects can be isolated from their environment. For instance, quantum computers currently operate at around minus 272 degrees Celsius. At higher temperatures, classical mechanics take over. Given that our body works at room temperature, one would expect it to be governed by the classical laws of physics. However, recent discoveries in quantum biology have shown that quantum effects can occur in living organisms, lending support to Penrose's ideas and encouraging further exploration in this field. Penrose believes that a deeper understanding of time and space is essential to comprehend the relationship between consciousness and the physical world, as current theories remain incomplete. In his view, new insights into the nature of space-time and its connection to quantum processes could help us uncover the true nature of consciousness. A crucial question in this quest is how to empirically test the connection between consciousness and quantum physics. As scientists continue investigating the nature of consciousness and its potential link to quantum processes, we may develop new experimental models to probe this relationship directly. The Orch OR theory and its implications also raise profound philosophical questions about free will, personal identity, and the nature of reality itself. These questions have puzzled philosophers for centuries, and advances in our understanding of quantum physics may provide new insight into these age-old mysteries.
We need new physics to understand consciousness. Now, when I mean new physics here, I mean something outside the physics we know, but it's not simply invented for the purpose of explaining consciousness. It's something which I think we need anyway for quite other reasons. First of all, there are various views about what is the basis of consciousness, and the current view is it's basically, well, the brain operates according to a computer, and many people believe this, and computers are, when they get powerful enough, will do the same things that brains do, and if brains make us conscious, then these computers will be conscious, and therefore computation itself is what provides consciousness. That's one quite a common view these days. If you don't hold that view, you probably hold the next view, which is that established science, the science where it works so well that we have now, that in some way this science comes together and some configurations produces consciousness. Or there's the third view, physics of the world, and that is what we need in order to explain consciousness. Or you might say it's nothing to do with science and something comes from outside. My view is number 3. There are many aspects of consciousness which I don't want to talk about, which most people do talk about. Things like, pain or love or perception of the color green or all sorts of things like that. I'm only concentrating on one thing, which is the concept of understanding.
As the scientific community explores the relationship between consciousness and quantum physics, alternate theories have been proposed, highlighting the need for more research and interdisciplinary collaboration to unravel the complexities of the mind and the quantum world. The potential impact of these ideas on artificial intelligence is significant. If consciousness is indeed linked to quantum processes, incorporating quantum physics into AI models might be necessary for achieving genuine artificial consciousness. This possibility raises ethical questions about the treatment of AI. If machines could possess consciousness through quantum processes, should they have rights similar to humans? Addressing these moral and philosophical issues is essential as AI systems continue to advance. Roger Penrose's ideas about consciousness and quantum physics offer a thought-provoking perspective on the nature of the mind and the universe. By exploring connections between these seemingly disparate fields, we can deepen our understanding of both consciousness and the fundamental laws governing reality. As we continue to learn more about the nature of consciousness and its possible links to quantum physics, we may find ourselves on the cusp of a new era of understanding, with profound implications for science, technology, and the human experience.